Exercise 1.3, question number 3. Find dy by dx if Roman 1 root x plus root y equal to root a. This is of the form implicit function. Implicit function is a function in which y we cannot solely have in the form of x and we cannot have x solely in the form of y. So differentiating with respect to x now, derivative of root of x, we know that it is 1 upon 2 root x, derivative of root of y 1 upon 2 root y, derivative of y is dy by dx. Now this 1 upon root x will go to that side and will become minus 1 upon root x. This upon 2 root y will go to that side and will become into 2 root y. 2 will get cancelled, then it will become minus root y upon root x. See here, 2 will get cancelled, it will be minus root y upon root x. That is root of y by x. Roman 2, it is x root x plus y root y equal to a root a. Root x means x raised to half. This is x raised to half into x raised to 1 in multiplication, addition of the indices. 1 plus half will give you 3 by 2. Similarly, 1 plus half will give you 3 by 2. Now differentiating with respect to x, we know that x raised to n is always n times x raised to n minus 1. So x raised to 3 by 2 will be 3 by 2. X raised to 3 by 2 minus 1, it will be half, plus y raised to 3 by 2. Y raised to 3 by 2 means 3 by 2, y raised to 3 by 2 minus 1, 3 by 2 minus 1 is half, into derivative of this y is dy by dx. Now equal to a raised to 3 by 2, that is constant. So derivative of that constant is 0. Now x raised to half means root of x, y raised to half means root of y. Now multiplying both the sides with 2 by 3, we can have root x plus root y dy by dx equal to 0. So dy by dx will become, this plus root x will go to that side and become minus root x. Into root y will go to that side and will become upon root y. So it will be minus of root x upon root y. That is minus of root of x upon y. Roman 3, x plus root of xy plus y equal to 1. This root xy, we can have it as root x into root y. Okay, now differentiating with respect to x, we can have derivative of this x is 1 here. First function root x as it is. Second function root y, derivative of that is 1 upon 2 root y into derivative of this y is dy by dx. Plus this root y as it is, derivative of root x is 1 upon 2 root x. Okay. Now this derivative of y is dy by dx, that is equal to 0. Once again, derivative of x is 1. First function as it is, derivative of second one plus second function as it is, and derivative of this root x is 1 upon 2 root x. Okay. Derivative of y is dy by dx. Now we will collect the terms of dy by dx. So it will be a root x upon 2 root y plus 1 times dy by dx. We can take out dy by dx common from these two terms. See here. Okay, it is root x upon 2 root y plus 1 times dy by dx. This plus 1 plus root y will go to that side and will become minus. See here, this plus 1 plus root y by 2 root x, that will go to that side and will become minus. Okay. Now by cross multiplication we can have root x plus 2 root y upon 2 root y dy by dx as it is, this minus sign as it is. Here it is 2 root x plus root y upon 2 root x. Now this 2 root y will go to that side and become into 2 root y. This into root x plus 2 root y will go to that side and will become upon root x plus 2 root y. This 2 will get cancelled. Now final answer is minus root y times 2 root x plus root y upon root x times root x plus 2 root y. Okay. Now question number 4. X cube plus x square y plus xy square plus y cube equal to 81. Differentiating with respect to x, we can have derivative of x cube. We know that x raised to n is n x raised to n minus 1. So x cube derivative of that is 3x square. Derivative of x square is 2x. But here it is of the type u into v. Therefore first function as it is, derivative of second, that is derivative of y is dy by dx. This second function y as it is, derivative of x square is 2x. Once again, this is of the type u into v, xy square. First function x as it is, derivative of y square will be 2y dy by dx, that is derivative of second function, plus the second function y square is as it is into derivative of first function, that is derivative of x, it will be 1. So it will remain y square only. Derivative of y cube is 3y square, but derivative of y is dy by dx. This 81 is the constant, therefore its derivative will be 0. Now we can have dy by dx common from these three terms here, 1, 2 and 3. What we can have in bracket, x square plus 2xy plus 3y square times dy by dx. All these terms 3x square plus 2xy plus y square will go to that side and will become minus. Okay. Now this into x square plus 2xy plus 3y square will go to that side and will become upon x square plus 2xy plus 3y square. Hence the answer. Now Roman 5 is x square y square minus tan inverse of x square plus y square equal to cot inverse of x square plus y square. Observation is the key here, because here it is tan inverse theta and here it is cot inverse of theta. This minus tan inverse will go to that side and it will become plus tan inverse. We know that tan inverse of theta plus cot inverse of theta is pi by 2. Once again, tan inverse of theta plus cot inverse of theta is pi by 2. Now differentiating with respect to x, we can have first function as it is, that is x square. Derivative of second function, derivative of y square is 2y into dy by dx, plus the second function y square is as it is into derivative of x square is 2x. Once again, first function as it is, derivative of second function plus second function as it is, derivative of the first function. Okay. Now we can have this dy by dx as minus of 2xy square upon 2x square y. We can cancel this x with this x and this y with this y. And 2 will get cancelled with this 2, and what remains is minus y by x is dy by dx. Roman 6. X e raised to y plus y e raised to x equal to 1. Differentiating with respect to x, we can have the first function as it is. Derivative of second function, that is e raised to y, is e raised to y dy by dx. Plus the second function e raised to y as it is into derivative of the first function x is 1 here. Now this second type is also u into v plus this y first function as it is, derivative of second function, that is e raised to x is e raised to x, plus this second function e raised to x is as it is, and this first function derivative of this y is dy by dx. Now derivative of constant, that is 1, is 0. Derivative of constant is always 0. Now we can take out dy by dx common from these two terms, and we can have x e raised to y plus e raised to x times dy by dx. This plus e raised to y plus y e raised to x will go to that side and will become minus. Now this into x e raised to y plus e raised to x will go to that side and will become upon x e raised to y plus e raised to x. Therefore, dy by dx is minus of e raised to y plus y e raised to x upon x e raised to y plus e raised to x. Roman 7, e raised to x plus y equal to cos of x minus y. Differentiating with respect to x. Derivative of e raised to something is e raised to that thing. Okay. Now, derivative of this x plus y we have to take equal to derivative of cos is minus sine of that bracket into derivative of this bracket, that is derivative of x minus y. Derivative of x plus y is 1 plus dy by dx. Derivative of x minus y is 1 minus dy by dx. Now, is e raised to x plus y into 1 plus e raised to x plus y into dy by dx minus sine of x minus y into 1 minus minus will become plus sine of x minus y dy by dx. Now, we can have the terms without dy by dx to the left hand side, that is e raised to x plus y minus sine of x minus y will come to this side and become plus sine of x minus y, and we will move this e raised to x plus y dy by dx to that side, it will become minus, and taking out this dy by dx common, what we can have here, sine x minus y, this plus will become minus here, minus e raised to x plus y times dy by dx. So dy by dx is e raised to x plus y plus sine of x minus y upon this bracket, sine of x minus y minus e raised to x plus y. See here. Now, Roman 8 it is cos of xy equal to x plus y. Differentiating with respect to x, derivative of cos is minus sine. Now, derivative of this inner bracket, that is derivative of xy. First function as it is, derivative of y is dy by dx. Second function y is as it is, derivative of x is 1 here. Now, equal to derivative of x is 1 and derivative of y is dy by dx. Now, multiplying this sine of xy into x dy by dx and this minus sine of xy into y, we will have minus y sine of xy, that is equal to 1 plus dy by dx as it is. Now, we can shift the dy by dx term with dy by dx towards the left hand side, and without dy by dx terms we can shift it to the right hand side. So this plus will become minus here. We can take out this minus sign also and this dy by dx also. What remains in the bracket? X sine of xy plus 1. Now, this into this bracket, that bracket will go to that side and will become upon. Okay, and this minus sign will shift to the right hand side. So dy by dx is minus of 1 plus sine of xy upon x sine xy plus 1. See. Okay. Now, Roman 9 is this e raised to x minus y. So, what I have done mistake here, by writing e raised to x minus y, I have written here e raised to x minus y. So, mistakenly the problem was read incorrectly, so I have to correct it now. E raised to x minus y, that is equal to x upon y. To simplify this function, we have to take log on both the sides. So log of e raised to x minus y is equal to log of x upon y. So this e raised to x minus y will come down. Say here, log of a raised to p is p log a. This p times log of a. So log of e raised to x minus y will be e raised to x minus y times log of e. Log of a upon b is log a minus log b. Therefore, log of x upon y will be log of x minus log of y. Log e is 1 here. So e raised to x minus y is equal to log x minus log y. Differentiating with respect to x. Derivative of e raised to something is e raised to that thing into derivative of this x minus y is 1 minus dy by dx. Because derivative of x is 1, derivative of y is dy by dx. Derivative of log of x is 1 upon x minus derivative of log of y is 1 upon y, and derivative of y is dy by dx. Now we can have these terms in dy by dx towards the right hand side, left hand side. See here, e raised to x minus y minus dy by dx. See here, and this minus 1 upon y dy by dx will come to this side and will become plus 1 upon y dy by dx. 1 upon x as it is, and this e raised to x minus y into 1, it will give you e raised to x minus y. That will go to that side and become minus e raised to x minus y. By cross multiplication, we can have 1 minus y e raised to x minus y upon y. Same thing here. 1 minus x e raised to x minus y upon x. This y will go up, and this 1 minus y e raised to x minus y will go down. So that upon will become into while going to that side, and this into will become upon here. Hence the answer. Now Roman 10 it is x plus sine of xy plus y minus cos of x minus y. Differentiating with respect to x, derivative of x is 1 here. Derivative of sine is cos of x plus y into derivative of this bracket, that is x plus y. Derivative of x is 1 here. Derivative of y is dy by dx. Here also derivative of y is dy by dx minus derivative of cos is minus sine of x minus y into derivative of x minus y. What is derivative of x is? X here it is 1. Derivative of y dy by dx. Now 1 plus cos of x plus y plus this cos of x plus y into dy by dx will give you cos of x plus y dy by dx. This dy by dx as it is, minus into minus will give you plus sine of x minus y into 1. It is sine of x minus y. This minus into minus will give you plus, into this minus will give you minus sine of x minus y dy by dx. So we can have the terms in dy by dx towards the left hand side. It will be cos of x plus y. Okay. This minus sine of x minus y will come to this side, will become plus sine of x minus y dy by dx. This 1 dy by dx will come to this side and become minus 1 dy by dx. Terms without dy by dx are on the right hand side here. It is sine of x minus y. This cos of x plus y will go to that side and become minus cos of x plus y. This plus 1 will go to that side and will become minus 1. So dy by dx is sine of x minus y minus cos of x plus y minus 1 upon this bracket. Into will become upon. After going to that side, it will become cos of x plus y plus sine of x minus y minus 1. Okay. So this is the exercise 1.3 question number 3, which is based on implicit functions. Please try to revise the problems. You have to solve the problems 4, 5 times. Each problem you have to solve it by your own after understanding the problem. Thank you very much. Thanks a lot.